Hey guys, in this session let us see literal and bind variable in Oracle. So first of all we need to understand what is literal and bind variable, and these two values are used everywhere, okay, in all the SQL statements that we execute. So wherever you see a where clause, right, so select star from employee. So this is an example where department ID is equal to 10. So here when there is a where clause, we call it as a predicate. So that predicate will be used to filter out the data, right? So if I select only from employees, all the data which is stored from the employees will be returned. But if I use this where clause with department ID 10, whatever employees who is having department ID 10 will be retrieved, right? So here we given some value. So this value is called as literal, right? And for bind variable, it is a placeholder. Okay, sometimes this may be confusing. Always for bind variable we will be using a colon before the value. Okay, and we will not give the exact value, we will give the placeholder. So this is called as a placeholder. Okay, so how the values are supplied? So we just supply the value as a variable. Okay, so this is the placeholder variable where we specify the values. Okay, so even the end user will not be able to easily identify the values when we execute the query. Okay, so it is very good for security. Okay, but bind variable may be useful in some cases, and it also has some disadvantage. Okay, so we every time whenever there is a parsing issue, we use a bind variable. Okay, but not always using a bind variable will be beneficial. Okay, so if you see, this improves the parsing efficiency and reuse of the cursor, right? So we know that Oracle has SGA, and inside the SGA we have shared pool, right? So inside shared pool we do the syntax check, semantic check, and the shared pool check. So we call it as a soft parse and hard parse, right? So when the values are already stored in the shared pool, then we don't need to again do a hard parse. But when the values needs to be newly generated, right, so the code that we return, so when Oracle already has the information, it will be easy. But when Oracle does not have, Oracle has to do a hard parse, because in library cache it needs to do all the, it needs to recreate all the code which is required for the query to execute, right? So for hard parsing issues we use the bind variables for sharing the cursor, right? So if one cursor can be shared by multiple code in the library cache, then it will be less parsing and less resource will be consumed. Otherwise, if each and every cursors are having a separate newly created cursors, then it will be very resource consuming, right? So these are the two values that we use in the predicates. Okay, and see, if in this example this is a bind variable, Oracle cannot see the actual value at the parse time, so it generates a general execution plan unless adaptive features are used. So this is where the problem arises. Okay, when we focus in terms of performance, Oracle loves to see this query with the literal values. Okay, but when Oracle sees this value, Oracle may not be understanding what exactly this value is. Oracle has to do something to understand this value. Okay, so in older versions it was very difficult for Oracle when the application developer use a bind variable. Okay, so but still using a department ID with the literal value will generate a lot of we can say parsing issues. So that is the problem. So when literal values are used, Oracle has to generate individual the Oracle has to parse this multiple times and also execute this multiple times. But when we use bind variables, Oracle can parse less time, but it can execute multiple times. So that is the first problem. Okay, but when we use bind variable, generation of the execution plan is the problem. Okay, because of the hidden values. Okay, so if you see value visibility, so it is known to the optimizer, so optimizer can easily generate an execution plan by seeing the values. But for bind variables, it is hidden at the parse time, so Oracle cannot see what the value is, and it will just generate a general execution plan. Okay, so we get performance issues even if we use bind variables. Okay, so parse efficiency, each unique literal is parsed. Here one parse for many executions, right? So if we have values like this 10, 20, 30, 40, 50, what Oracle does is Oracle will parse for each values 10, 20, 30, and what it does, it has to generate a separate code for each and every values in the shared pool. Okay, so this is where the hard parsing issue come into picture. Okay, but when we use bind variables, how Oracle see these values? So it just use the placeholder. Okay, so it will just parse only one time, because we have only one value in the predicate, and what it does, it will execute multiple times for each and every values that we specify in the variable. Okay, but execution of the query will be generic, but generation of execution plan will get affected, right? So if Oracle generates only one execution plan for all these values, then just imagine. So here I have given only 5 values, right? So imagine if there are thousands of values or millions of values. So if there are say for example, so for department ID 10 there are 10 employees, for department ID 20 there are 1000 employees, for department ID 30 there are 10,000 employees, for department ID 40 there are 9 million employees, for department ID 50 there are 1 employee. Okay, so in this case, just imagine if Oracle generates a generic execution plan for all these values, all these results, would it be efficient? So just think in generic term. So it will not be efficient. Okay, so just imagine if Oracle is generating an execution plan with index scan. Okay, just assume. Okay, so index scan will be beneficial for this 1, this 10, maybe for this 1000, and just imagine if it may or may not be efficient for this 10,000 and this 9 million row data. Why? Because if you see, majority of the data is fetched for 30 and 40. So if we use an index, then it will be a lot of work for Oracle. Index scan may not be efficient for 30 and 40, but it will be efficient for others because only few data is retrieved out of huge amount of data. So that's the use of an index, right? So we cannot use an index scan for scanning majority of the data from a table. So for these two cases, full table scan may be efficient. Okay, so this is where using a bind variable, Oracle could not see what the value is exactly. Okay, and it will just generate a common execution plan which will not be efficient for all the values. Here only I have given 5 values, but if there are thousands of values, then a lot of queries will get affected, right? So here Oracle can generate individual execution plan for every SQL. So the execution plan estimation will be efficient. But here there is a parsing issue. For each and every query, Oracle has to individually parse. So that's the advantage and disadvantage of using both the values. Okay. So here the plan quality, it is optimized for that specific value. Here may be generic unless adaptive cursor sharing is used. So we'll see what adaptive cursor sharing. Okay. Here let us see the problem. So before Oracle 9i, the query with the bind value, optimizer sees only with the placeholder, assumes uniform data and general execution plan for all the values, right? So I already explained this. So we will not be having uniform distribution for every values that we fetch. So uniform distribution means, as I already told you, for 10, 20, 30, 40, 50. So for 30 and 40, the amount of data that we fetch is very high. But for 10, 20 and 50, it was less. So here there is no uniform distribution of rows that we retrieve. For 30 and 40, it is very high, but for 10, 20 and 50, it is very low. So uniform distribution means it should be something like this. So for every values that we fetch, it should be somewhere around 1000, 1200, 950. So this, we can consider this as a uniform distribution because all the data that we fetch are uniform. So if we generate only one execution plan, it will be efficient when we use bind variable, right? So that's where lot of bad execution plans were generated for skewed data. So I'm just explaining the history of Oracle. Okay, so here the data is skewed, right? So but here the data is not skewed. Here uniform distribution is there, but we cannot guarantee uniform distribution for every data that we retrieve, right? Data will generate in any form. It may not be always uniform. Okay, so for solving this problem, what Oracle does, Oracle introduced bind peaking. Okay, so what is bind peaking? Bind peaking means it is just peaking the bind, that's it. So in the previous versions before 9i, Oracle was blindly generating an execution plan for the bind variables, right? So in 9i, Oracle can peak. Oracle can see what is the bind value. So say for example, this is the placeholder, department ID. This is the variable. So Oracle can peek inside. So consider this as an I. Okay. So this I can peek inside the variable container. and see what are all the values, 1 2 3 4. So it may go on. So it will just peek one by one and then generate an execution plan. It will not directly access all those values inside the placeholder, but it will just see. So you can imagine as an X-ray scan. So using an X-ray we can see the bones inside the body, right? So likewise Oracle has some X-ray vision. So with that vision it will just peek all the bind variables. Okay, so Oracle peeks the bind variable value, then uses histogram and generates one plan. Okay, so why histogram is used? Because of the data skewness, right? If data is not uniform, then we use histograms. Okay, so even when we use bind variable peeking, we have another problem. Plan fixed based on the first bind variable. So the same example we can take 10, 20, 30, 40 and 50, and this contains 1, this contains 1000, this contains 10,000, this contains 9 million, this contains 10. So here Oracle will peek the bind variables. Okay, and it will just peek the first value, which is 1, and what it will do, it will just generate an index scan, index execution plan for this first bind variable. Okay, so it will just fix it, fix this plan. Okay, so if the same SQL statement is executed with another bind variable, then it will use the same plan for all the executions, whether it is 10,000 or whether it is 9 million. So here Oracle has to use full table scan, but still it will use index scan. That's the problem with bind variable peeking. Okay, so before bind variable peeking, optimizer will generate an execution plan, but it will not be knowing what is the value actually. It will just blindly generate an execution plan. Okay, so after this problem, Oracle can see the values, bind variable values, but still Oracle will generate only one execution plan for the first bind variable. So it will just fix that plan for all the upcoming SQLs which are executing with the bind variables. So that is the another problem. Okay, so to solve that problem, Oracle has introduced adaptive cursor sharing. So adaptive cursor sharing, what it does, it will just monitor the runtime performance when using the bind variable. Okay, and it will just detect the variation in the execution patterns automatically. So DBA don't need to do anything, and then it creates multiple child cursors. Okay, so each optimized for a value range. So adaptive cursor sharing solved this problem, but still even using an adaptive cursor sharing may not guarantee that Oracle will generate an good execution plan. Okay, but this problem was fixed. So here what it does, Oracle peeks the bind variable of only the first query, and it will generate only one plan. But here Oracle dynamically monitors every query with the bind variable. Okay, it will just peek the bind variable as well using whenever it uses adaptive cursor sharing. So after peeking the values, it will detect the variation in the execution patterns, like the distribution in the data, right? So the data is skewed, so it has to create multiple child cursors based on the selectivity. Okay, so I will explain all these, we'll see in practical as well, so that you will understand. So based on the selectivity, Oracle will group all the SQLs, and based on that it will just generate a separate execution plan. Okay, so each optimized for a value range. So what was the solution? It was bind aware and value sensitive plans. Okay, so optimizer becomes bind aware. So adaptive cursor sharing was introduced in 11G. Okay, so this is a test case. Okay, so we'll just see how Oracle handles the data. Now let us just see both the SQLs. Now if you see, both these SQLs are considered separately because of the SQL text. For this SQL, different SQL ID is generated. For this SQL, different SQL ID is generated, because all the SQL text are same, but only the literal values and bind variable are different, right? So here something we are using some placeholder, here we are using literal values, right? So in this case, optimize the Oracle will not be able to share the cursor. Oracle has to generate a separate parsing information for both these SQLs. Okay, and the child number is 0. Okay, so we have two columns, is bind aware and is bind sensitive. Okay, so in $SQL we have these values. So these three are the columns, is bind sensitive, is bind aware, and is shareable. Okay, so now let me just execute the same query. Yeah, so the first column is bind sensitive, second column is bind aware, and third column is shareable. Okay, so what are these three columns? Okay, these three columns are very important to understand the queries which are executed with the bind variables. Okay, so here if you see, is bind sensitive indicates whether Oracle monitors the bind variable values for a SQL statement to determine if those values affect the execution plan. Okay, so this is we can also call it as a bind peaking, whether Oracle is using a bind peaking to peak the values, peak the bind variable values. If it is yes, then the cursor is bind sensitive. Oracle is watching how the bind value is affecting the performance. If it is no, then it is not bind sensitive. right? So before 9i, Oracle 9i version, all the SQLs that are executed will not be bind sensitive because the feature itself was not there. Bind peaking feature was not there. But after 9i and till 11g, Oracle has improved the way how optimizer sees the bind variables. So Oracle will wash the bind variables and it will check whether the values are affecting the performance and also the execution plan. Okay, so a cursor becomes bind sensitive when Oracle suspects that a bind variable may affect the selectivity, therefore the execution plan. Okay, so based on the selectivity, Oracle will understand if a particular query will affect the performance or not. Okay, so this is an example. A query using var department ID is equal to this placeholder might return vastly different rows for department 10 and department 90, right? So here department 10 is a small department, but department 90 is a large department. So we may not be getting the same rows for both these values. So that's how Oracle understand. Okay, so is bind aware? So this indicates whether Oracle has adapted the execution plan based on the bind values. Okay, Oracle has become bind aware and can generate different plans for different values. Okay, so in the previous example, Oracle will observe the bind sensitive means Oracle will observe the values, but for bind aware, Oracle becomes adaptive. Adaptive means Oracle will create a separate child cursor and it will determine the plan based on the bind value. Here directly Oracle will segregate the type of queries and it will generate a separate execution plan. Okay, so bind aware means the cursor sharing, which was introduced in 11g version to improve the performance. But here bind sensitive means it is kind of bind peaking. You can understand in that way. Bind peaking. Here this is adaptive cursor sharing. Okay, and the next column is shareable. So this is straightforward, whether the SQL can be shared or not, that's it. Okay, not the SQL, the cursor which is having the SQL can be shared or not. If it is shareable, then it will be Y. If it is not shareable, then because it may be because of the different environments. Like when I execute the query, I execute it with the different optimizer settings. Okay, so cursor sharing is important for memory efficiency and performance. If many users run the SQL but cursors are not shareable, Oracle can waste the memory in the library cache. Okay, so this is where we force the cursor sharing. Okay, so literals allow only Oracle to fully optimize for specific values, which is useful for skewed data. Okay, bind variables allow SQL reuse and reduce parsing overhead, but may lead to inefficient plans if not paired with adaptive cursor sharing. Okay, so both have their advantage and disadvantage. Okay, so now if you see in this SQL, we have for the first SQL we have these three columns, and if you see whether it is a bind sensitive, yes. So now Oracle has peaked the bind variable value. What is the bind variable value? It is 10. That's why here it is Y. Whether Oracle has generated an adaptive plan? No. Why? Why? Because we executed this query only for the first time. So we need to execute multiple times with the bind variables. Then only Oracle will be able to adaptively see whether the query is affecting performance or not. So at least we need to execute it for 10 times or 20 times. That depends on the environment. Okay, even if we execute for 5 times, sometimes Oracle will be able to generate an adaptive plan, even if we execute for 50 times sometimes. So that depends on the data and how we execute the queries. Okay, so after some time we will see bind aware as yes, and whether it is shareable, yes, because we are using bind variable. Okay, and executions are 2 because I executed this query for 2 times, right, in SQL Developer. And if you see, plan hash value are same for both literal and this bind variable, right? So why for both the SQL's plan is the same? Because even if I use bind variable, I am using the same literal value. So Oracle may be peeking the bind variable and it has generated the same plan for both the SQLs, even though the SQL text are different, right? Even SQL IDs are different. If you see for the second literal value, child number is 0 because this query is executed only for 1 time. So what is the bind sensitive column? It is no, because here we don't use bind variables. So definitely this column will be no. Whether it is bind aware, no, because we are using literal. This is nothing related to bind variable. So these, whenever we are using literal, these 2 columns will be no. And whether it is shareable, yes. Okay, and executions 1. So this is how we will observe how Oracle is executing. So only for bind variables, these 3 columns, I mean not these 3 columns, in bind sensitive and bind aware will be useful. Is shareable will be useful for both literal and bind variable queries. Okay, so in the next section we will see the challenges before bind peaking. So we already I already explained this, but we'll see in the next section in more detail about the challenges.